Good morning, everyone. Myself, Kishan Shinde, currently pursuing my engineering at Sri Venkateshwara College of Engineering. Today's topic is typical ResNet architecture. So let's dive deep into this topic. Introduction to ResNet architecture. ResNet stands for Residual Neural Network. It was introduced by Microsoft Research in 2015. ResNet is known for its ability to train very deep neural networks effectively. So you could see in the image here, the image shows so how many levels of process it undergoes to build this architecture. So the motivation of residual learning is the traditional deep learning suffers from vanishing gradient problem. So vanishing gradient problem is a greater problem or a big problem that a deep neural network will suffer. So to overcome that, we use residual learning. Residual learning aims to address this issue by using shortcut connections. So it uses the shortcut connections. So whichever the connections it could be making to eliminate the vanishing gradient. So it takes a shortcut connection. These shortcut connections allow the network to learn residual functions. So here in an image, you could see the shortcut connections that is being made from the hidden layer to the output layer. So and the output is being given out. Building blocks of RSNet. The basic building blocks of RSNet is residual block. The residual block consists of two convolution layers with a shortcut connection. The output of the shortcut connection is added to the output of the second convolution layer. So in the image, you could see the convolution of 1 cross 1, batch normalization, convolution of 3 cross 3, batch normalization, convolution of 1 cross 1, batch normalization. So in the second diagram, you could see here the convolution of 1 cross 1 batch normalization, convolution of 3 cross 3, and batch normalization, and convolution of batch normalization. But in first image, there is a shortcut that is being created for convolution of 1 cross 1 batch normalization directly to the output. So this is the building blocks or the architecture. Stacking residual blocks. RSNet architecture typically stacks multiple residual blocks. Deeper RSNet models have hundreds of layers. Stacking residual block allows the network to learn complex features. So in the image, you could see the residual blocks that is being made up here. So there might be hundreds of layers to build a deeper residual blocks. So it helps it to learn complex features. Skipping connections. Skipping connection in RSNet allows the network to bypass one or more layers. So the skipping connection helps with gradient flow and alleviate the vanishing gradient problem. Skipping connection enables the training of very deep neural networks. So the connections could be skipped in this way as image given here. So it could jump from one layer to another to obtain the output. Residual learning concept. In residual learning, the network learns residual functions instead of direct learning the desired underlying mapping. The residual function is the difference between the input and output of the block. This approach simplifies the learning process and improves the performance. So, as X is an input and plus is an output here, so the difference between this both uh, gives us the residual function. So a residual function could be f of x, and subtracting this might give us the residual function. Types of ResNet architectures. ResNet architecture come out in different depths, such as ResNet 18, 50, 101, and 152. So deeper ResNet models tend to have better performance, but requires more computational resources. So requirement of computational resources is the must in a ResNet architecture. So the better computational resources you have, the better performance and the better, bigger, deeper model could be developed. The choice of ResNet architecture depends on the specific task and the datasets. As this line explains on its own, the task or the work to be done from the given input is the way how RSNet architecture is being built. Training RSNet models Training models requires a larger data set and significant computational resources. Techniques such as data augmentation, batch normalization, and learning rate scheduling are commonly used. Pre-trained RSNet models are available for transfer learning on new datasets. So pre-training RSNet models are also available, wherein this model is already being prepared for data for a given data sets. So these data sets could be manipulated or changed to our requirement and get them results for it. So the building of model has a technique such as data augmentation, batch normalization, and learning rate. So all these parameters contribute a lot in building the model and training the model. Benefits of ResNet. ResNet architecture has been widely adopted in various computational vision tasks. ResNet models have achieved the state-of-art performance on image classification benchmarks. ResNet skips the connections of residual learning concept, having influenced in the design of other neural network architecture. So these are the benefits of ResNet architecture, and the applications are image classification, object detection, and transfer learning. So ResNet models are widely used for image classification tasks such as identifying objects or scenes within the images. They have achieved the state-of-art performance on benchmark dataset like ImageNet. Object detection. ResNet serves as a backbone architecture for many object detection such as faster RCNN, YOLO model, you only look once, and SSD, single shot multi-box detector. The deep features learned by ResNet are crucial for accurately localizing the classifying objects within the image. Transfer learning. Pre-trained ResNet models trained on the larger scale dataset like ImageNets are commonly used for feature extractor for transfer learning. By fine-tuning these models on smaller domain, the specific dataset one can achieve good performance even with limited label data. Conclusion. The ResNet architecture has revolutionized deep learning by enabling the training of very deep neural networks. The use of skip connections and residual learning has proven to be effective in improving gradient flow and learning performance. So ResNet continues to be popular choice of various computer vision tasks due to its performance and versatility. So I hope you understood from today's topic a little bit about ResNet architecture. Hope you would like this video. Uh, Please do like and share, subscribe. Thank you.